All right, so this is 4.3. We're going to write a linear function now, not from a word problem like yesterday, but from a graph, and we're going to use function notation. All right, so got to make sure we can write a linear function that's regular. So these are in the first quadrant, right? So there's 0, 4, the y-intercept. Let's make sure we can do the slope here now. The rise is 1, the run is 3, right? Because it's 3 boxes and 1, and you can do that between any two good intersections. And so this is, let's use linear function notation. So this would be f of x. Oh, I should have written x and y there. Right? This would be f of x equals 1/3 x plus 4. Okay. And this one, there's the y-intercept 0, 8. Now, they are the good intersections. And zoom. All right, so we're going down 2 and over 1. All right, so you could have written y equals mx plus b, but I'm going to use f of x equals negative 2x plus 8. The y-intercept is 0, 8. The slope here is negative 2. The function is going down. Okay, so we're going to be doing this for like the height of a tree. So this tree, when it was planted, you can see is 15 feet tall. Okay, and it's growing some amount of every single year. And it turns out that that rise there is not 1, it's 5, right? Because that is from 15 to 20. Every time that's 5. The run here is 2 boxes, but the slope there is 5 halves, and that's the number one mistake people will make on the test. So let's make sure we understand. On a real world graph, you can't just count boxes, you have to know what a box is worth. Okay, so what I was just telling you, to be careful about scale. One box is often not worth 1 unit. All right, so find the slope and y-intercept. So the y-intercept is right there. So the first box is halfway to 24, so that must be 12. So it goes 12, 24, what must be next? 36. So the y-intercept is 0, 36. Now, the slope here looks like 1, and it is not. Okay, why is that? Because we just said, and this number right here is going to be key every time. We just said one box is worth 12, right? Going up. Going along the bottom, on the run, one box is still worth 1. So what's the slope here? So the slope here is 12. So let's write, this is x, oops, y, and this is x. But we're going to write f of x equals 12x plus 36 is the linear function in function notation for that line. All right, so now we're going to add real world to that. Oh no, we're going to practice a bunch because I've had such problems with this in the past. All right, so find the y-intercept. More importantly, find the slope. There are the good intersections. Right, you go down and then cross. Now, this is 1, 2, 3 boxes, and a box along the bottom seems like 1. So the run is 3, but what is the rise? Well, look right there. One box is worth 6. So the slope here, rise over run, is 6 over 3. And so the slope is 2. The y-intercept is this 12, and so this is f of x equals 2x plus 12. All right, let's do the next one. There's the y-intercept. This is pointing down. There's another good intersection. So let's look down here. All right, so it's 1 along the bottom, but this is the key. It's not 3, right? One box is worth 25. So this is 3 of those, and they're going down. So what's the rise? The rise is negative 75. So the slope here is negative 75. And so this is f of x equals negative 75x plus 200. That's the linear function in function notation for that graph. Right, and if you're doing this without the printout, you just go like that. You put the 200, you go like that. You show your slope as negative 75. All right, we can write a linear function for any situation that can be graphed as a straight line. The slope is the rate in the problem. I said this in the last lesson, and it's still true today. Now this one, one that started at 0, 0, you should have done in 7th grade. All right, so the y-intercept of this is 0, 0. And now this is pay as a function of hours. The more you work, the more hours you work, the more pay you get. Now we got to find this slope, right? So it's all good. So what's one box worth? 12. What's one box worth on the run? 12, a 1. So this is 12 over 1. The slope is 12. What does that mean? Right? It means he's getting paid 12, I didn't say dollars, but let's assume dollars per hour. Right? This is hours. That's what that means. The rate is always the slope. And the rate is always going to be right in front of our input there, our independent variable. And since it's 12h plus 0, that's the answer. Okay, so let's find our y-intercept. It's 0 what? So a box is worth 12 again. So our y-intercept is 0.36. Now we're going over 1 and up 2. Now a box along the bottom is worth 1, but it's not, the rise is not 2. It's 2, but they're worth 12 each. So what's the rise? 24. So our slope here is 24. What does that mean? That means the cost to rent a boat, let's understand this, must be $24 every hour, right? It was $36 just to get the boat. And now we're going up $24 more dollars every hour. That's what's going on. Please understand what these graphs mean. Okay, so the cost per hour, or cost of a function as a function of hours, is right $24 per hour plus the $36 that you got as a deposit or an upfront fee. What is the value of C of 2? So C, what's the cost at 2 hours? Well, 24 times 2 is 48, plus 36 is, what, $84. So let's make this money. Right, it's $84 to rent that boat. Now, that should be a point on our graph. Let's see. At 2, we're right there. Is that the point 284? Well, let's see. Is 84 this line halfway between 72 and 96? Sure is, right? Because we're going up by 12. And it may be, when you do your homework, that you want to fill these in, all right? Find the cost to buy apples at a price club that only offers apples in 1-pound bags. All right, so you can't buy 1.5 apples. So what kind of function is this? Hopefully you're saying the word discrete. This is a discrete function where I didn't draw the line through it, right? I didn't draw the line through it. It's a discrete function. You can only buy in 1-pound bags. All right, so the cost of these apples is a function of the pounds of apples. And turns out, is this a price club? Yes, so the price club has a $24 entrance fee or membership fee. So that's our y-intercept, right? So you buy 0 pounds of apples, you still pay 24. Now, let's look over here. So the run here is 2, right? And the rise is 1 box. But what's the rise? 1 box is worth 6. So the slope here, right, is 6 over 2, or what is it? It's $3 per pound, right, for these apples. So it's C of P equals 3P plus 24. What are the domain and range of the discrete function, right? The domain, right, you could have in your inputs, you could buy nothing and pay 24, and you could have 1. Now, 1 is there, just because I skip over it, right? You can buy 1-pound bags, 2-pound bags, 3-pound bags, right? That's what you can buy. You have to understand the real world consequences. The range here, you're going to pay $24 if you buy none. Then what's next, right? There are 3, right? They're $3 per pound. So the next number on the list is 27, right? And the next number on the list, add another 3, is 30. We're going up by 3s. So that is our range of the discrete function, right? So it is discrete, but we draw this line so we can see the slope and compare it to all the others. All right, the rate of this water is descending down. The tank is leaking. All right, so we're doing height as a function of time. This looks like it's going up by 1, 17, 18. This looks like it's at 19 to me. Notice these are all plus, and they're never plus, but this is going to be a negative, and we got to figure out the slope here. So there, right, get more than just one intersection. And so we're going down 2, and a box is worth 1 here, so it's going down 2, I didn't say inches or feet, but something 2 something per unit of time, hours, all right? H of t equals negative 2t plus 19. All right, so that's our function. What is the value of h of 5? So at 5 hours right there, right, what should this value be? Let's see, h of 5 equals negative 2 times 5 plus 19, negative 10 plus 19 equals 9. Let's assume this is feet, but so 5, 9, yeah, that's at 5, 9. What is the value of h of 10? All right, so h of 10 equals negative 2 times 10 plus 19, negative 20 plus 19. That equals negative 1. Is that what we want to say? No. Let's say h of 10 is what? It's 0, right? Because we have to understand this is a real-world graph. Before it gets to 10, the water is leaking out of a tank, right? So we have to know that. So h of 10 is actually 0. It's not going to go down beneath the tank. Right, this car has been driving, and write a linear function in proper notation for the distance. All right, so we're going to do m for miles as a function of hours, and it starts at what? Each one of these is worth 25, so the y-intercept is 75. Now the slope, right? The run here still is 1. 2 boxes going, but each box is worth 25. So how fast is this car going? This car is going 50 miles every hour. That's what this means. Slope here is 50. So we wrote a function. What is the value of m of 5? So 50 times 5 plus 75. 250 plus 75 is what? 325? And that's miles. It's a word problem. Let's make sure. Let's see. 5, right? So 5 is off the graph, right? And why is it off the graph? Because it's up here at, right? It's up here at 325. 5 goes with 325. All right, the flower grows. This is a flower growing. Okay. Now, this one, boxes are small, but each box here is worth 2. I think that's really the key to this problem. So the y-intercept is 12. So the height is a function of days. So it started at 12 inches. It says that. And how fast is it growing? Okay, well, every intersection's good. The run here, the run is 1. But what's the rise? The rise is 1 box, but it's 2. So it's going up 2 inches per day. The rate of growth is 2 inches per day. So h of 11 is 2 times 11 plus 20 plus 12. 22 plus 12. 22 is 32, 34 inches. So let's see that. H is 11, and you go up there, and we should be at 34, which is 1 box above 32, right? That's the point. 11, 34. All right, this is a candle burning. 1 box seems to be worth 1, so that's 13. So it's the height as a function of time, right? I'm doing that so I don't get h of h. You can have h of h, but it's awkward. All right, so now we know this is negative, right? Because it's going down. Now let's see this. Let's find the good intersections. Okay, so now this is 1, 2, 3. So this is the run here is 2, and the rise here is negative 1. So it's going down ½ an inch per hour. The candle's burning ½ an inch per hour. Negative 1/2 t, mine's a little sloppy, plus 13, right? Could you write negative 0.5 t plus 13? Yes, but why? The slope is negative 1/2.